In this lecture, we're going to learn about constants. And a constant is a variable you can initialize when you are declaring it, but you can't change it later on. And if you try to change it, you're going to get a compiler error. Here we have an example. We have an unsigned int, which is a constant, and this is how you say that your variable is a constant. You prefix it with the const keyword, and you're going to initialize it like we initialized any other variable. But later on, if you try to change this earth radius, you're going to get a compiler error. And this is really the basic meaning of a constant. You can have constants of different types. For example, you can have doubles, you can have strings, you can have all kinds of crazy things. And if you flag it with the const keyword in front, you're not going to be able to change it after you have initialized it. And one thing you should know is that the const qualifier doesn't really apply to the data that you have in memory. It doesn't apply on these zeros and ones that really represent our radius. They apply to the variable name. So if a variable name is qualified with const, you can't go through that variable to change the data in memory. So the CPU doesn't really have this concept of const. The concept of const lives in your C++ program, and it is used and understood by your compiler, and the compiler is going to stop you if you try to go through this name and modify this piece of data. So protection is not at the memory level, it is at the C++ program level, or the name that you use to manipulate your variables. This is what I mean here, and I really hope this makes sense. Okay, so if it is possible to have some other variable name manipulate the same piece of memory, and that variable is not protected by const, you can actually violate the constantness of this piece of memory. You can go through this other variable and modify it. And it is really as if you had some kind of protected item inside the room, and you have a door that can only go out to read things from that valuable thing, but you can't go in. You see that the door that goes in had this little symbol to mean that it is closed off. You can't go in to modify this thing, but you can get things out of this thing and read from it. This is the meaning here. And if by any kind of technique you can set up another door on the other side of the room that allows people to go in, they are going to go in and modify this thing. And from this door here, you're not really going to know because you think this thing is const. It can't be modified and nobody can go in. And I think C++ protects you from something like this. You can't have two variables that are working on the same piece of data in memory. But if it was possible, you would go through this variable and modify a variable that is otherwise const from the perspective of earth radius here. This is really what I mean. Okay, so why do we use const? We use this to guarantee that our variable will never change after it is initialized. And that's throughout the entire lifetime of your C++ program. Here are a few examples again. We have our earth radius. We can initialize it with braced initializer. We can use functional initialization or assignment initialization. All this is going to work. This is going to be interpreted as declaration and initialization. You can't declare a constant and not initialize it with a value. If you try to do that, you're going to get a compiler error. And you can't try to modify a constant. That's the real meaning of this. If you try to do this, you're going to get a compiler error. You see here, we're trying to put in another value, which is 7,000. We're going to get a compiler error. Even if we try to increment it, we're going to get a compiler error. And this is really good. Constants can be involved in other computations. For example, our const variable here can be used to initialize another variable. Why not? We have expanded radius, and it is 3 times the earth radius. And what you're going to be really using here is a copy of this value we have stored in earth radius. And if you print this out, you're going to get what you expect. 3 times the earth radius. Okay, every time I explain this to students, I get this very common question. When should I use const? My best practice is to really try and use const everywhere I can, because that's going to protect you from modifying the variable if you don't really want to modify it. And if I want to modify it and I get a compiler error when I try to modify it, then I'm going to remove const, and I am playing on the safe side here. Okay, another thing is that using const is self-documenting. Whoever sees your variable is going to really see that you don't intend for that variable to be modified. And again, you get compiler protection if you try to modify that, and that's really cool. Okay, this is really all I have to share about const. I think it is time we went to Visual Studio Code and actually played with a few of these concepts. Here we are in our working folder. We are going to copy our template files and put those in our current project, which is constants. So we're going to do that. And we're going to open this up in Visual Studio Code. We are going to open main.cpp, and we're going to remove whatever it is we don't need here. And we're going to try and declare a few const variables. Why don't we put a net and call this age and initialize this with 34, for example? Why not? If we try to print this out, we're going to see it on the console. So we're going to say age, and we're going to put this out. Nothing special here. We're going to open our terminal, and we're going to try and build this with GCC. If we run this, we're going to see the age printed out. But if we qualify this with const, nothing's really going to change. If we try to build again, the build is going to go through, and if we print it out, we're going to get the same thing. But if we try to modify this, we're going to get a compiler error. If we try to change this age, for example, to 55 and try to build, you see that before we even try to build, we have Visual Studio Code helping here. And it is saying expression must be a modifiable L value. So what this really means is that for this expression to work, age must be something you can modify, but it is not something you can modify. So if we try to ignore this and build, we're going to get a compiler error, and it is going to say assignment of read-only variable age. Age is const, so it is read-only. You can only read from it like we did here, but you can't modify it. Okay, so let's say this. This is really the protection you get from const variables. And it is not only going to work for integers. You can have a double const or a float const. Let's use float here for the sake of an example. And we're going to say const float. And let's say this is height, for example. And we're going to initialize this with 1.67. Why not? Let's say this is your height. And we can print this out. So we're going to say height, and we can build. This is going to build fine because we're not trying to modify it. Build is good. And if we print this out, if we run our Rooster program, we're going to see it printed out. And notice that we forgot our suffix here to make it clear that this is a float. So let's go in and put this in. And if we try to modify this and say, for example, height equals 1.80 float, and we try to build this, we are going to get a compiler error. Again, we can't modify a constant, and we can have constants of all kinds of crazy types in C++. Okay, so let's comment this out because there are a few concepts we still need to really try out. Another thing we have seen is that you can't declare a constant and not initialize it. So for example, if we took out our initializer here, we should get a compiler error. And you see that even Visual Studio Code is going to flag this as a problem. Const variable age requires an initializer. So if you don't initialize this, you're going to get a problem. And if we build this, we're going to get a compiler error. And the error is going to say uninitialized const age. If you have to declare a constant, you have to initialize it. And if we initialize it, everything is fine now. If we build, we're going to build fine. The error is going to go away. And if we run this, we're going to have everything we expect. Okay, another thing we have seen is that constants can be involved in other computations. So for example, we can have a variable called years, and we can initialize this with 3 times the age of somebody. Why not? And if we print this out, that's what we're going to get. We're going to say stdcl age years. If we build, the build is going to go through, and we can print this out, and we can run our program to see the years to be 102, and that's 3 times 34 here. So you can use your constants in computations. You just have to be aware of the protections that your compiler is giving you here. When your variable is flagged const, you can't modify it. You have to initialize it if you are declaring it. And these are really a few things you need to be careful about when using constants. And again, protection is at the variable name level. So you can't really go through this age variable and modify the data that is in there. And this is really what we mean here. I think this is all we set out to do in this lecture. I hope you have a better understanding of what a constant is. You can have all kinds of crazy constants in your program, and the meaning is really going to be the same. You can't modify that thing if it is already initialized, and you have to make sure it is initialized when you declare it. If you don't do it, you're going to get errors. You can see the errors in your IDE or editor if it is as good as Visual Studio Code. But even if you don't get help from your IDE, you're going to get a compiler error if you try to compile and violate the constants of your variables. We are going to stop here in this lecture. In the next one, we're going to learn about constant expressions.